Well, this year we've been celebrating the centenary of the Institution of Chemical Engineers. My name's Nigel Hirst and I'm Deputy President of IChemE. I have with me Jane Cutler and Professor David Bogle, who were both privileged to hold the position of President during the year. Well, welcome to you both. The centenary project, which we branded ChemEng Evolution, has been 2 years in the creation and is the work of over 100 volunteers, both members and friends of IChemE from across the world. You'll find it online as ChemEngEvolution.org. Our key slogan is a centenary of achievements, a future of success. We spent 50% of our effort looking into the future and see an important role for chemical engineers in the sustainable development of the planet over the next 100 years. To frame the project, we chose 9 themes based on the United Nations Sustainable Development Goals, known as the UN SDGs. These highlight the enormous contribution that chemical engineers have made to the world in the last century. And they also provide a lens through which we can identify the actions chemical engineers should take to help society evolve in a sustainable way. So, David, you've seen the webinars. What themes meant the most to you?
Well, of course, there's a lot of really interesting stuff, but I'm going to pick out 2 in particular. The first, I think really has to be the sustainability and environment work. This is right at the heart of what we do as chemical engineers. We're really key to helping to solve those, mitigate the climate emergency and to find solutions. As chemical engineers, we have that great skill set. The particular skill set is the idea of thinking of things as systems. This is right at the heart of our training, the way that we think about things and how we think about systems and try and look at holistic solutions to this huge problem we have in front of us, and really using those sustainable development goals to really plough ahead and make our great contribution that we can do. So that's got to be the biggest one. But the other one I wanted to bring out was reflecting the sort of wider footprint that chemical engineering is really has been moving towards. And in particular, the 2 I thought I would bring out was the healthcare one. Obviously, where we spend a lot of time and have been at the heart of manufacturing, so there's a lot around smart manufacturing of medicines. There's quite a lot in there about that, but also the role that we can play in access to medicines across the world, so that it's not just making them; it's providing a much broader access to medicines. So healthcare is one, and I think we can have more role in the way we think about the body and its how the medicines affect us and so on. The second one then was the built environment area, which is perhaps not one where people have thought about chemical engineers having a role to play, except in creating fuels. But I think there were some really nice thoughts about really optimizing the flow through the built environment of all materials and energy and waste and things like this, as well as producing the fuels and the energy supplies and how we use those energy supplies. I think we can really play a part in that built environment. So we've got a much broader footprint than was as many people conceive of chemical engineering.
Do you think that the term chemical acts as a bit of a barrier to the wider understanding of what we do as a profession?
I don't think it acts as a barrier. It has a problem because people think about chemicals as some problem, but people forget that water is a chemical. It's not just the toxic chemicals that people think about. So I still think it's the right name for us, but we do have to be better at communicating the broader contribution that these various chemical entities make to our standard of living, our way of life, through everything that we do.
Thank you. Jane, you've seen the webinars as well. What spoke to you?
The key one for me was actually energy and the role that chemical engineers will play in the energy transition. It's clear that most or all countries around the world, governments and communities, are making decisions to reduce their carbon footprint, but it's not going to be instantaneous, and if we're not careful, there will be unintended consequences. And the burden of the energy transition won't be necessarily felt in a fair and just and equitable manner. And we may, if we're not careful, shift one set of problems to another set of problems. And I think that's where chemical engineers and chemical engineering come in, because it's about applying systems thinking so we get the lowest net impact, whether that's financial or environmental or safety. And that brings me to the second theme. There's a lot of conversation about hydrogen, ammonia, methanol as enablers of a lower carbon energy future. I think conventional fossil fuels will be around for a while, but whenever we talk about new chemicals being used in a much broader way, and we talk about new ways of storing energy in things like batteries, we actually need to apply our process safety thinking and say what could go wrong, who could wear the consequence of this going wrong, and make sure we don't lose sight that these things are, in some cases, explosive, non-breathable, toxic. They're not without their own challenges, so they need robust engineering solutions. And the third theme that really touched me was actually materials. We can be a lot lighter in our use of resources. We can reuse, repurpose, recycle, but we can also say, is this the best material for the job? How do we get it with the lowest transportation miles? How do we get it with the lowest processing impact? Is this really, in a systems-wide approach, the most sustainable solution for the particular problem or opportunity? So that really are probably the three areas that jumped out to me as opportunities, massive opportunities for chemical engineers to make a contribution.
Thank you. David, you're an academic and an educator. What do you think these challenges mean for education and training in the future? Well,
certainly coming out of the discussions in evolution and even going broader than that, there were lots of interesting things about technology, but which is certainly revolutionising and has revolutionised recently the way that we design and deliver and engage in the educational process. But perhaps most interesting out of it was coming across a need for greater flexibility, so that we can really, so allowing our young people to really go with their passions, go with their interests, so that there's real flexibility in the curriculum that allows to explore this breadth of topics, breadth of new potential employment areas, problems that we're able to solve, still building on that core skill set of chemical engineering. There's a load of technical skills that we have that allows us to tackle these big sustainability problems. But beyond that, I think we talk too much about teaching and not enough about learning. So it needs to be facilitating learning and facilitating this more flexible learning. It's just quite a challenge for us in the universities, I may say. But also encouraging chemical engineers to speak out more, have the confidence to speak out more about the contribution that we can be making. That comes back to your point about chemical engineering and what we do. And I think sometimes we're just seen a little bit too to below the radar, and because we're not encouraging, training, developing young people in particular to get out there and talk much more about the great contributions, the things that they're doing, the huge impact that it's having on society.
I've heard that, or I've read that a third of an engineer's knowledge is out of date within 5 years of graduating. And the person who wrote the article was talking about learning, unlearning and relearning. Where do you think IChemE have a role in that relearning for chemical engineers who've been some years out of university?
Well, I think this is through the whole professional development space that we encourage, we develop, we provide through IChemE. Remembering that at university it's very much about the principles, the fundamental principles don't change very often. Physics doesn't change that often, but it does, but not that often. So what we see is, and we have been encouraged, and I think this is the right thing to do, to bring more in current problems, current interesting challenges that are going on in society. But of course, those are the things that change. So those are the things that indeed do need to be not forgotten, but sort of parked and move on. And that's where continuous professional development can really explore and develop how we apply these things, and the very specific technical knowledge that needs to be known in particular domains, and particularly in these newer domains where chemical engineers are working.
Yeah, I could jump in and add to that. I think we have a really good practical example. When in our era, none of us had heard the term sustainability, and probably most of us had not heard of the UN Sustainable Development Goals because they probably weren't invented back in the dark ages. IChemE last year, or earlier this year in January, launched a sustainability hub. And part of the goal of that is to put relevant and contemporary training. So not just people like us, but people all through their careers, from students, early career, and mid-career and senior professionals, can actually update their skills and knowledge in sustainability. And that will allow us to have more effective conversations in the organisations that we work in, but also in our local communities. So massive opportunity for chemical engineers to actually not just make a contribution in the workplace, but help their communities understand that there is no such thing as a free lunch. There is no easy, cheap, quick solution to many of the challenges of making our communities more sustainable, and educate the people that are in the community to actually make better decisions that meet the needs of their own communities. So it's very complementary to the evolution work, but it's a really practical example of how we adapt the professional training that's available within IChemE and many other places. And I would encourage people to think very broadly of what constitutes professional development. And it's not always about the latest deep technical thing. It can be about sustainability trends and tools and things as well.
Thank you. Everybody's talking these days, it seems, about net zero. And so what do you think, Jane, this means for chemical engineers today?
Well, I think it's a tough challenge because we actually need to think about the carbon footprint of every decision that we make, whether it's in a personal, in a community, or in a workplace sense, so that we understand that just because you are reducing emissions here, if the whole value chain, the whole system is no net change, well, we haven't achieved anything for all that effort. So the system thinking comes in to say, is this the lowest carbon way of achieving whatever goal it is? the most sensible way of doing it, because every time there's an energy transition from sunlight or wind to electricity, into hydrogen, into a truck to drive it along, versus direct use, if possible, of the sun or the wind, minimal storage, however it is. We need to minimise energy transitions. We all know, and the physics hasn't changed. Every time there's an energy or a material transition, there's energy lost, and that's the challenge. There will be, for a lot longer than we anticipate, use of hydrocarbons, hopefully with carbon capture and storage. So we have to make sure that, to the best of our ability, we make robust decisions based on evidence and data and not headline emotion.
And do you think there's a role for chemical engineers in educating politicians, or spreading this knowledge more widely to the general public?
I think there's a role in all of us to educate, whether it's at the micro, how you make better decisions in your home, turn the thermostat down, turn the lights off, whatever, but at a community level, at a workplace level. And for it's nice to think that politicians will listen, but it's really important that we work with the departments and the policy advisors so that they're getting good information from a range of sources, and then they can make whatever decision they make. But they need to, as far as we possibly can, make sure it's based on good information.
Thank you. David, you've been talking a lot recently about the importance of ethics to the engineering professions. So could you talk a little bit about what that means to an individual on the career of being a professional engineer? How should ethics inform and guide their day-to-day work?
Well, the key strapline from the report was think ethics before action. So it's really about guiding everything we do, and really thinking about the ethical consequences of the actions that the recommendations or the guidance or even the decisions that we make, and that's quite a challenging prospect for everybody. Some people, and it's not these are not clear-cut decisions often, and it requires therefore real discussion and exploring of different viewpoints. But to me, therefore, that's at the heart of what being a professional engineer is all about, and certainly being a chartered engineer is saying, I sign up to these ethical principles. In this particular case, the ethical principles on the Engineering Council was published some years ago. So it's a sort of statement of values that I, as a professional engineer, I stand up for these values, because I know that the impact that my work will have impact on society, and therefore it needs to be seen as and be considering the various viewpoints in an ethical way. So it's a sort of value proposition for being a chartered engineer, but it's also very important about drawing young people into engineering as a profession. Young people want to have, they want to tackle these sustainability challenges. They want to work for have an ethical professional career, and feel they're really making a positive contribution. So, being clear and encouraging or developing these ethical mindset, I think, is really right at the heart of what we do, and what we really need to do at university too, to be talking about this much more, to give people the language to be able to have these conversations. I feel we don't do this enough. It comes back to what I was saying before about, us getting out there more, being able to communicate much more with society, because we need to be having these conversations about what the ethical consequences are, and therefore the way we do that is by practicing, by having those discussions in a safe space at university, so that when we go out we have the language and we have the competence, which I think we do give them, but I'm not sure that we yet give them the language.
Thank you.
And I guess that's another opportunity for training for the IChemE that we perhaps need to put on the list and tap into. But summing it up it's not just what is being done or proposed, it's how. And why, and other unintended consequences, and if so, what are they, and who wears that consequence, and is it fair?
Yes. Yeah.
Thank you. Jane, you've had a leading role in process safety in Australia, and we've talked quite a bit in ChemEng Evolution about new technologies. Where do you see the risks of some of these new technologies in process safety terms?
I think continued focus by chemical engineers on process safety. So there's a lot of emphasis in workplaces on the safety of individuals, but actually the integrity of the process. And if that process can lose control and stored energy come out in a big rush and have the consequences of significant harm to people or the environment, it remains really critical, and we need to ensure, as far as possible, things fail safely. If they're going to fail, we build processing plants and things in the future with a case for safety underpinning the design and the operation. And I think it's as important in the next 20, 30, 40, 50 years as it has been in the last 20 to 50 years. And as we introduce more new technology under a time pressure, because we want to achieve the transition quickly for the benefit of the planet, we have to be even more careful that we haven't forgotten something.
Can I add a little bit to that? It's about, again, the communication of the fact that there are safety issues, but there are benefits. There's the trade-offs with the risks. And again, we need to be getting out more and engaging with people so that they really see the benefits and are willing to take those risks. That's a very difficult area because, a lot of people want a risk-free society, which just doesn't exist. So we just need to be talking, being clear about what those benefits are. And again, it's part of the training and development of professional engineers that they're really equipped to do this.
Yeah, and it's the some people place great emphasis on zero lost time instance or zero medical treatment instance. Well, it's not necessarily a leading indicator that your process has integrity and won't fail. So we need to be really clear that people don't muddle their thinking in this important area.
Good point. Well, there's a wealth of interesting and, dare I say it, exciting information on the ChemEng Evolution website. We have 2 guest lectures coming up, one about life cycle analysis and one about the importance of process safety. And they'll be shown on the Evolution website shortly. And I do encourage everybody to take a look at this wonderful repository of knowledge which has been created by volunteers, as I said. We will be keeping the site live for the foreseeable future, and we hope that it will continue to both inform and inspire the direction of chemical engineers, the chemical engineering profession, the institution of chemical engineers, and indeed other engineering organisations well into the next 100 years. So thank you for watching this, and we look forward to seeing you again soon.